Hi, everybody. Welcome to Mondays with Mike. It is now officially hurricane season, and so a lot of the topics are going to be based on getting you prepared for hurricane season. So today, I want to focus mostly in on the cone of uncertainty. Yes, the cone of uncertainty. It's what you're going to see really, anytime there's a tropical depression, tropical storm, hurricane, you want to know where it's going. And we usually have a good idea of where it's going, but we have a cone of uncertainty because there is uncertainty in the forecast. We're going to talk about what that means, and I'm going to relate it to baseball because for some reason I always just default to sports analogies when trying to describe things like this. So first things first, when it comes to using the cone of uncertainty, well, where does it come from? Well, do you know it's only been around for a little over 20 years? I mean, there have been a lot of other attempts to sort of express where a storm is headed. Just using a line is pretty ineffective, right? Because storms are very big. I mean, you could have storms that have wide-ranging effects of many hundreds of miles. And so focusing in on a line is not going to work. There also, and I'll show you here coming up, there have been experiments in using circles to give an idea of error, or forecast uncertainty. So let's get into it. Of course, I did bring my whiteboard because you know how much I love that. So I'm going to be using this to demonstrate a few things for you. By the way, lighting in here I know is weird. I'm trying to brighten myself up, but this is just the way it is. So I do have some data here for you. I'm going to look at my phone here because I don't remember the exact numbers. So if I were to ask you, what is the average error? Like, in other words, how inaccurate is a hurricane forecast 24 hours out? So if you were to take where the hurricane or tropical storm is now, and then the Hurricane Center's forecast of where it's going to be in 24 hours, what's the average amount of error? 50 miles. That's pretty good. You know, the trend, I do have the trend right here. So back in 1990, the average error was 100 miles. So they've made a vast improvement. They've cut that error in half. And as a result, as we'll look at here, the cone is getting smaller. The cone is getting skinnier because the certainty is going up. When you look at 72 hours, so basically 3 days out, the 3-day forecast has an average error of only about 100 miles based on the last 5 years. Now, if you go back to 1990, the average error was 300 miles. I mean, that's a huge improvement, and a lot of that has to do with computer technology, supercomputers, faster computing programs, or programs that could be run faster that take in much more data and can process it much faster and all of that stuff. So instead of having a 300-mile error, it's now down to 100 miles. And in fact, the 5-day forecast has an average error right now of about 150 miles, which is amazing. And that error back in 2002 was almost 400 miles. So that's also been reduced. So as a result, the cone of uncertainty has gotten smaller and smaller over the last several years. So let's talk about this. Why a cone of uncertainty? Well, I'm going to explain this hopefully in a couple of ways that make sense. First one will be weather related. The second one I'm going to bring in sports because that's just the way I think. So what you've probably noticed is you're going to have a storm. We'll show the storm like that. That's one of the storm symbols you could use to symbolize a hurricane or a tropical storm. Let me draw that bigger. I'm looking at it in my monitor here and it looks like it's way too small. So let's do this. So that's our hurricane or our tropical storm. Now we know that it's moving this way, let's say. We know that basically it's moving in this direction. Well, let's say here's the Gulf Coast, okay, and there's Florida. So we know it's moving in this general direction. But how certain are we of where it's going to be? Well, I just told you. So the average error for 24 hours out, let's say it's going to be right here in 24 hours. We know that average error is about 50 miles. So you can draw a circle around it like that, okay? For 3 days out, and let's say 3 days it's going to be somewhere like here, we have an average error of 100 miles, which would give you a circle like that. Now, one way of expressing hurricane uncertainty is to draw a bunch of circles like this. Basically, to take the forecast hour, so here's 24 hours, and here's 72 hours, and to just, for each one of these, put a circle. And that's okay. I actually sort of like this a little bit more than the cone, because the cone makes you, sort of leads you to believe that the error is only like left or right, up or down. But the error is actually, will it be moving faster, meaning that it makes landfall earlier, moving slower so that it's out over the water longer, or will it go, sideways, either way of the track? If you just draw a cone, and this is basically what the cone is based on, is these circles. So we'll draw a cone like this, and a line like this. Sorry, that's kind of sloppy, but that's what the cone is. The cone is just based on a bunch of circles, error circles. The problem with not including the circles is this, is that the cone will look like this. It'll kind of come out like this. And then there'll be a line in the middle, which is like the center path. And that cone can be useful, and then it can also be not useful. And I'll tell you where the circumstances are that it's going to be useful. So if a storm is very far away, and I'm talking about many days away, let's just put ourselves here. I'll put an H for H-town. Okay, so here we go. If there's a storm that's way down here, okay, let's call it, this is a tropical storm, TS. If it's way down there, and let's say it's 3 days away, and we have a cone that looks like this, well, that could be pretty useful, because it lets folks over here know that maybe you're not going to experience that much in the way of a direct hit. And it also might let the folks, let's say in South Texas, know that you're probably not going to get a direct hit. By the way, this is probably a good time for me to tell you, this is, the cone is where the storm historically ends up 2/3 of the time. That may be surprising. This encompasses where the storm ends up being 2/3 of the time, which means that 1/3 of the time it's outside of this cone. So it may end up that the storm is over here or the storm is over there because there is some uncertainty. But that being said, as the forecast gets better and better, the storm ends up in the cone more and more often. And like I said, the cone is getting smaller. So let's say 20 years ago, the cone, there may be a forecast track like this, and then the cone will be huge, like that, because of the uncertainty, because of the fact that the models weren't as good and the forecast wasn't as good. But now, with the higher certainty, there still is uncertainty, but with the higher certainty, the cone might be more like this. So it's a smaller area. So in this case, the cone is useful because it helps us to pinpoint an area where you might have to start thinking about evacuating the coastline. You might have to finalize some of your plans on where you're going to go if you're in an evacuation zone. You might have to start thinking about, if you're a city manager or some governor or a mayor, do you start declaring a state of emergency? Do you start doing voluntary evacuations? Do you start sending response teams to certain areas just in case? So that's why all of this is useful. But I want to talk about when it's not useful. And this is one thing we're going to focus heavily on this year. We started talking about it last year. But I think it's very, very important. So I'm going to use Florida as an example. And it's not that we can use Texas as an example too. But I want to use Florida as an example because this happened with Hurricane Ian. All right, so let's just draw the Florida Peninsula. That is a terrible Florida Peninsula, but let's just say that's Florida. All right, and then we'll put like Louisiana over here. So you have a hurricane that's located right there. Okay, that's your hurricane. You have a cone of uncertainty that looks like this. Let's say it looks like that. And then the middle line is pointed here at Tampa. Remember that? This is when the cone doesn't work. This is when you don't want to focus on the cone. Why is that? Well, because at this point, it's Hurricane Ian is what I'm talking about, which was a Category 5 that made landfall as a very strong Category 4 and brought, incredible amount of damage to the southwest coast of Florida. You'll notice that if you lived right here, you're not in the cone of uncertainty. You lie outside of the cone. And so you may be thinking to yourself, all right, well, we dodged a bullet there, right? We're going to get close, but not a big deal. That was a big mistake. And in fact, it happened 20 years ago with a hurricane that was in almost the same spot named Hurricane Charlie. Same deal. When you have a coastline and a track that's almost the same direction as the coastline, the cone can cause some really serious problems. And what happened with Ian is that instead of following the middle of the cone, it followed the far right-hand side of the cone, and in fact did something like this. Taking away the cone, though, if all you were told was that there was a hurricane right here, okay? There was a hurricane right here, and if all we did was pay attention to warnings issued by the Hurricane Center, then you would have seen here that there were, and I don't remember the exact area, but let's just say this whole area of the coastline was under hurricane warnings. Hurricane warnings in this case are much more important than the cone. We learned that here with Hurricane Harvey. Hurricane Harvey did not hit Houston. The center of circulation hit Rockport. Rockport, I've never been to Rockport. Rockport is all the way down near Corpus Christi. That's the area that took a direct hit from the eye of Hurricane Harvey. But we had, probably the worst storm in our history, at least as far as rain. So it would have been a terrible mistake to focus on the cone of uncertainty with Harvey and just to assume that it doesn't really pose a threat to Houston. Same thing happened to folks in Florida, where even though this whole part of the coastline was under hurricane warnings, the folks down here, or at least the national media, did not focus on that location. They were focused here because that's where the center of the line was pointing. And that was a tremendous mistake because this area here had some of the worst storm surge, ever seen in that part of the world. So the cone The cone of uncertainty is good, is useful when a storm is far away. It becomes very much something that we don't want to focus on when a storm is, let's say, within 24 hours or even 48 hours of landfall. So why is that? Well, let's take a look here at the Texas coastline. And again, I'm going to draw this just roughly. And down here we'll put Brownsville, Beeville, exclamation. And here we'll put Corpus. Okay. And then here we'll put like Galveston. And then over here we'll put Port Arthur, which people call Port A. Or don't they do that for Port Aransas, right? So let's just put in, because I think Port A actually is Port Aransas, which of course is like there. So if we have a hurricane that's here, and it's a big one, and let's just say that the cone of uncertainty looks like this. Is that a concern for Houston? You better believe it. Because the effects of a hurricane are much larger than just this little area that ends up inside the cone. And so as the storm gets closer and closer, okay, then the cone becomes less useful. Let's say the storm is here. This is what I'm using for the hurricane. Actually, it's a low, right? I shouldn't put an H in there. Tropical system. We'll put TC for tropical cyclone. So now you have this cone that's like this, and we live up here. And you have to say, well, okay, I'm looking at the cone and it looks like we're in the clear. No, we're not. Because for a couple of reasons. First of all, the storm is huge. And so we could get significant rain, flooding, storm surge, tornadoes, all of that, even though we're very far removed from that infamous cone. Also, it's important to remember what I said. The storm ends up inside the cone of uncertainty 2/3 of the time. So 1/3 of the time, it ends up outside of the cone of uncertainty. So what if it takes a jog to the north and gets closer to us? Now we're looking at more wind, more rain potentially. So that's why the cone of uncertainty is good, far away, and it is not a good thing to focus on when the storm is close. Now, I want to use a baseball analogy here to talk about the cone of uncertainty. So we are going to imagine here that the Astros, who are, not having the best season, but they're doing okay. So let's just say that Bregman is at bat. Okay. So I'm going to draw a very, very rudimentary baseball field here. Okay. So this is home plate, which looks like that, I think. And then here's first base, second base, third base. All right, and then da-da-da-da-da. You know what a baseball field looks like. And then let's just call this the outfield. Okay. Now here's the thing. If you have a batter here, we're going to put Bregman here. Okay. And we'll put the pitcher here. Okay. So let's just say there's a pitch. The pitch represents, the ball represents a hurricane. Stay with me on this one. The ball represents a hurricane. The ball is thrown toward the plate. Okay? We think that there's a good chance that Bregman is going to make contact with the ball because he's been on fire lately. He's, whatever. He's making good contact with the ball. This would be the equivalent of a computer model showing us maybe a week away that there might be a low forming. He might hit the ball. He's probably going to hit the ball. But can you make a forecast as to where the ball is going to land? No way. I mean, he hasn't even hit the ball yet, right? So if somebody asked you, is it going to be a pop fly to left field? Is it going to be a home run to right field? Or is it going to be a ground ball to the second baseman? There's absolutely no way that you can predict that. And so this is very important for those social media posts that people will put up for a hurricane 16 days into the future, showing it hitting some part of the coastline. That would be the same thing as trying to predict where the baseball is going to be before he hits the ball, literally. So keep that in mind. So now we're at the stage of the storm hasn't formed, he hasn't hit the ball yet, but we think he's probably going to hit the ball. All right, now, boom, he hits the ball. Okay, so Bregman makes contact with the ball, and let's say the ball's moving like that. Now we have a little bit of certainty, a little bit. The crack of the bat and him hitting the ball is equivalent to, okay, the storm has formed. We have an area of low pressure. Now we can start to make some predictions about what's going to happen with it. Because now we can look at the ball and say, okay, is it bouncing off the ground, in which case we know it's going to be a ground ball? Is it popping up, and what kind of angle? Is it popped? You can kind of tell when somebody's going to hit a home run versus it just popping up and being an infield fly ball or something like, or foul ball. But at this point, we could start to make some predictions about it. We could say, well, it looks like it's going to go foul, so it'll end up over here. We could say it's moving really fast. Maybe it's going to end up in the outfield. So we can at least start making some predictions, right? As the ball travels farther and farther, let's say it's now over the shortstop's head and it's still going. Now we have even more certainty, right? We can eliminate, it's not going to be a foul ball. It's not going to be a ground ball. It's not going to be an infield fly ball. So we can start eliminating things. So the level of uncertainty is going down and the level of certainty is going up. It's like a storm that now we know it's a hurricane or we know it's a tropical storm, and we have a rough idea. Whoops, my light went out. And we have a rough idea of where it's going. I think I lost my light. That's okay. So we have a rough idea of where it's going now. Going to the outfield. We don't necessarily know if it's going to be a home run, but now the announcer is saying, it's a long fly ball. That's like us knowing that a hurricane's going to come close by, right? Now, let's say it keeps flying and it's getting near the warning track. It headed for the Crawford boxes at Minute Maid. These are the final preparations for the outfielder who can now see the ball coming with high certainty. He's underneath the ball, right? Now we know that that cone is real small and we have a high amount of certainty about where the center of the hurricane is going to go, where the ball is going to go. Even the people in the crowd can see the ball coming at them. This is the equivalent of a hurricane coming at you. Okay, so now let's say it finally lands in the stands and somebody's happy that they got a ball. Hurricane makes landfall. Now, again, this person out here who caught the ball, it would have been impossible for him to know that the ball was coming his way before Bregman hit the ball, right? You might be able to guess and say, hey, I'm ready, right? That's like being ready for hurricane season, okay? I'm ready if the ball comes our way. I brought my glove, right? Or I'm ready to catch it in my hat. Or maybe put the beer down because the storm might be coming your way or the ball might be coming your way. So we're prepared, right? Once he cracks the bat and the ball starts going, now all eyes are on the ball. All eyes are on the hurricane. But we don't know where it's going. The cone of uncertainty is wide. Now it's zeroing in on its target. and you have higher certainty, so the cone is thinner. The one big difference is that a baseball is this big, and a hurricane is big. So imagine if instead of one baseball coming, you had a giant baseball. I don't know how else to put this. You either have a giant baseball or you have, hundreds of baseballs coming at you. I don't know. Think about it however it makes sense to you. But let's just say the baseball, instead of being that big, the baseball is this big, Then you would definitely want to know that we can't just track the center of the ball, because you might get smacked by the giant baseball over here. So I hope that makes some sense. If as far as hurricane preparation, that if you are at an Astros game and you are sitting in the Crawford boxes, you are the equivalent of us living on the Gulf Coast. You're in a place that gets hit often. Home runs go to the Crawford boxes at Minute Maid often. When a right-handed batter is at bat, you know that you need to be on alert. That's like hurricane season. When the batter, let's say Bregman, hits the ball, now you know we're watching a storm and I need to be prepared because the storm could be coming our way. And then finally, if it's a fly ball, you can see it coming at you with more and more certainty. Now you know you need to make final preparations. Do I duck? Do I reach out and try to catch the ball? You need to make those plans, right? And those reactions. So I know it's a weird metaphor maybe, but it's the way my mind works. Hopefully it helps to explain it to you, how being at a baseball game, watching a Bregman home run, is similar in the way you think about it to preparing for a storm hitting. The only difference is that you need to imagine that the baseball is gigantic. It's not just covering a little area, it is going to splash the crowd. And that's why I don't want you to focus just on the cone. It's very useful for preparing when the baseball is far away, but if you had a gigantic hurricane-sized ball coming at you, you know you need to take cover from this thing if it comes anywhere near you. So I hope that made sense. I like any excuse to break out my whiteboard. Shout out to my mom and Neil. I am running out of time here. And I want to thank you very much for joining me here for this edition of Mondays with Mike, Baseball Metaphor Edition. See you next time.